Hey, Jody here. This video is brought to you by my online store at weldmonger.com. Let's do it. Today we're welding up some holes in some 050 stainless steel. This is a super common task in several industries like automotive, aerospace. We're going to compare the difference between welding up stainless steel with no backing, no argon shielding, with aluminum backing, and then with argon shielding. So for this first hole, I'm not using anything. It's just exposed to air on the backside. And when you melt stainless steel, when you penetrate fully through something and it's exposed to the atmosphere on the backside, you get something called sugaring. And it's a non-technical term for excessive oxidation. It's granulation. And it's bad. It provides all kinds of crevices and nooks and crannies for bacteria to grow. And that's horrible for food service or pharmaceutical work. But it's also just a mechanical defect. It's just a bunch of stress risers, a bunch of pits, and it's just not a good situation. Also, it requires a lot of heat. When you got all that excessive oxidation on the backside, it requires a lot more heat just to flow the metal and to get the thing filled up. So I started off with just a little hole, and I've got quite a little plug there before I got it finally filled up. And isn't that lovely? That looks like crap. Fido's butt. So we're going to get better than that. We're going to put the next one against a piece of aluminum backing. And what that's going to do is a couple of things. Number one, it's going to provide a lot of heat sink, which is helpful on stainless steel. Number two, it's going to trap the argon and kind of provide a little shielding actually. And number three, it's going to kind of mold the penetration. It won't let the penetration drop through. Now, copper is even better than aluminum, but a lot of people don't have a chunk of copper laying around. I save little drops of aluminum and copper of all shapes and sizes for a little task like this. But if you don't have a chunk of copper, aluminum is the second best thing. So I'm using a little jazzy tin cup here that lets me extend the electrode out there where I can get the camera angles that I need so you can see the arc here. But this one's going to go a whole lot better. I'm going to be able to keep that heat confined to a really small area and just kind of, it takes a lot less time also too to get the hole filled up with the aluminum backing clamped to the back side here. I do a little swirl at the end as I let off the amperage. That's to prevent leaving a little crater eye. And you can already see if you had to grind these down or sand these down flush, that second one would be a lot easier to do than the first. Especially on this side. You wouldn't even get all the defects out of the first one. This one would take minor sanding or minor blending and we get it right down nice and smooth. Now let's try an argon purge box. Or as we used to call them when I worked for Delta, a backup box. Now these little devices are very common in aerospace work, and it seems like every aerospace shop has their own sort of design on how they make them, whether they use perforated copper or perforated stainless, or even aluminum. But the benefit in copper is that it's so thermally conductive, you can clamp it directly to the back side of something and it won't melt. Now it's really easy to make these. Basically it's just a sheet metal piece that's kind of broke and welded on the corners, a tube that goes the whole length with holes drilled in the back side where it has to go through this diffuser material, and then you just weld up the perforated copper and sand it off if you want, or just leave it. A dual flow meter is usually part of this equation, or you have to have a whole nother cylinder with another flow meter. The amount of flow that you need is determined by the size of the surface area of the backup box. And for this one, I run at about 20 CFH. This little box is roughly 2 inches by 3 inches. You just have to do some trial and error there. So I'm just going to clamp it with a pony clamp to that backup box. And the trick is not to have too much flow coming in there so it's not fighting against your cup gas. If you have too much flow on the backup box, it will disturb that shielding, and you'll see, sometimes you'll see sparks and everything. It'll create a turbulent area in there. But as long as you kind of lick the back of your hand and just feel a nice soft flow, usually you're good to go. So this hole's about sealed up, and we'll compare it to what we did against that aluminum backing here in just a second. You can see a little difference in the size of the plug there. So the aluminum backing definitely drew heat out better and therefore provided a smaller weld, which could be beneficial as far as distortion and things like that. And also if you've got to grind it off, it's going to be quicker. The main point here is whether you use aluminum backing or copper backing or argon shielding, it's way better than using nothing.